Alright guys, so this is to help with the homework that I just gave you for tonight on rate laws. The video that you took guided notes on is gone over this already, but the way that we write rate laws is really all about how concentration affects the rate of the reaction. So we write with respect to the reactants. In general, if we have A plus B yields C plus D, A and B are the reactants, so the rate law is going to be written with respect to those two reactants, in this case A and B. So the general form we use is rate equals K times A to some power and then B to some power. The rate is the speed of the reaction. It's usually in units of like molar per second. It could be molar per minute. It could be molar per hour, but it's concentration over time. K is the rate constant. This guy is differing in its units, and we'll go over that a little bit later. And it's also always present in these expressions, and the number that is associated with it can vary as well. A and B are in brackets, and brackets mean molarity or concentration, and then X and Y are the powers at which they are two, and they are different. X and Y are not stoichiometrically based, so you can't base them on the stoichiometry of A and B over here. X and Y can only be determined experimentally and are said to be the orders of the reaction. Now, X and Y typically are going to be equal to 0 or 1 or 2 or 3. I haven't really seen anything higher than that before. So we're going to go over how to get a rate law expression from experimental data, and that's where number 3 on your homework comes in. We're going to skip to number 3 because it's a better example than number 2, and I'm going to do 3, and then you should be able to do 4 right off of 3. And I would consider number 2 as like a challenge question more than anything else. So for number 3 on homework, we have this reaction. You have HgCl2 plus 1/2 of the oxalate ion, C2O4 minus 2, yields Cl minus plus CO2 plus 1/2 of Hg2Cl2. So we only really care about the reactants in this case. So we're going to write the rate law expression with respect to these reactants. So it's going to look something like rate is equal to K times the concentration of HgCl2 to some power times the concentration of C2O4 minus 2 to some power as the generic formula. Letter A is asking what is the order of the reaction with respect to HgCl2 and with respect to C2O4 minus 2 and overall. So they want us to find X and Y. To find X and Y, we have to use the experimental data that's provided to us. So the way that you want to approach this is to focus on, I usually just focus on HgCl2 because it's the first one. So we want to find a spot where HgCl2 is changing concentration while C2O4 minus 2 is not changing concentration. Because that way we could see how does changing the concentration of HgCl2 affect the rate over here. So we want to find, we call this like experiment 1, experiment 2, experiment 3, experiment 4. We want to find 2 experiments to compare where HgCl2 is changing and C2O4 minus 2 is not changing. So if we look closely, what are we going to choose here?